All right, hey, welcome back to Mechanical Pros. Here with Jeff Smith. We're talking about VFDs today. What do we got going on? Looks like a training demo, huh?
Yeah, what we got is we here at MRG, we use our Yaskawa training demo, not only just to train our own people, but we do put on classes, and we also use it to try to work out our field situations as well, BAS connections, fire alarm, that type of stuff. So today we're going to kind of demonstrate it, and let me explain it to you first. What we have on the demo, we have two sides to the demo. On this side here is a 3-contactor bypass demonstration. And what it is we still use the cube that's on the other side. And then what we have is we have the keypad. And if you'll look at this diagram here, it gives you a display of the primary contactor, the bypass contactor, and the output contactor. So this is a full functioning bypass control.
Okay. This is a whole demo. We can simulate probably anything, not anything, but.
We can simulate most everything in the field. The only thing we can't really simulate well is load, because I only have a fan basically and a small horsepower motor in there, so I can't really look at current or kW usage or anything like that. But those are some of the things that are important to a lot of the BAS contractors.
Yeah. So we got this from Yaskawa.
Yes.
Demo we used to train the industry on Yaskawa.
Yes.
And we can use it to train technicians, but you also use it to load programs, sequence operations, and then we can transfer them to whoever's in the field. They can test it out.
Right.
Well, I guess we can test it here before we send it out, and then they can verify it in the field.
Right. What we can do, and we do this a lot for our customers, is if they send us a scope of work and a wiring diagram, we can simulate their wiring diagram and all of their programming that are building specific. Then what we can do is we can either load them on a flash drive from the computer, or we can load it into a keypad that we loan to them, and all they do at that point in time, plug it into the drive, hit download, and the program that we've built for them is already there.
Yeah.
Saves a lot of time.
All right, yeah, that's awesome. So Jeff, walk me through kind of the process you do and how you get value out of using the demo.
The demo, like I said, it's set up for most field operations, and remember, Yaskawa, when they build their drives, they look at it as an open architecture. In other words, they don't know what they're going to be walking into. Is it going to be completely communications, or is it going to be hardwire control? What you see here is hardwire control. If you'll notice here on the side, these little switches, if you'll notice there's 8 of them. Those are the 8 switches that are on the bypass control board that are contact closures. So if I want to run this drive, I have my speed adjustment here, which would be an analog, and it could be from a building automation, or it could be from a potentiometer, just like this. We can go ahead and run the drive, and if you'll notice, you'll see the fan starts turning, and if you can see on this, the upper line of logic that we see is what we're telling it to run at. The second line is what we have for what we're actually running at. Now, since we're simulating field process, most of the time if we're on AHUs or cooling towers or anything like that, we have safety circuits that we have to account for. So I've already programmed in this demo would be like a safety, a high static.
Yeah. And
what would happen is we'd have a high static or a free stat, and you would get this action. And if you'll notice, the drive goes ahead and shuts off. Once it resets, it goes ahead and starts right back up.
Yeah, got it.
Okay.
So you're setting a max duct pressurization so you don't blow your duct out.
That's exactly
right. Which basically just shuts the fan down.
That's exactly right.
Got it.
So the second one we have, I have 2 that are programmed on here. The second one would be like if we were on an exhaust fan, where I had to wait for a damper to open before I started pushing air. So we have what we call a BAS interlock.
Yeah.
That would be the second switch. And so same thing, it would preclude operation. The minute I turn it off, I get the alarm. It tells me that interlock is open. That way there it gives me a troubleshooting guide as well. I know where to go look for my problem. So we can simulate that and account for that too. Now the other things that we have, and these are kind of application specific as well, because in every installation that we do, new building, old building, whatever, there is a fire alarm that has to go along with any air moving device. And so there's generally going to be a fireman's override. Now what a fireman's override is that means that the fireman's going to come in and he's going to take complete control of this drive. And the reason he wants to do it is he may want to shut it completely off so that they can put the fire out. Once the fire's out, they need to evacuate the floor of all that smoke so they can get in there and knock down any other fire that's left. So there's generally going to be a fireman's override panel. He's going to come in and he's going to has a key switch When he hits that key switch, you'll see a function like this. It immediately flips over to bypass, and this is what we call run to destruction. And what that means is it ignores any safety input. Remember, John, a minute ago we had high static and we had damper in switches. I can put both of those switches open and it doesn't do anything. It will not shut the drive down.
We don't care about any of that stuff because the primary objective is to get smoke or whatever out of the building.
It's fire life safety
Gotcha.
at that point in time. Now, we're an end device. We are not a control device in fire life safety, but we have to be controlled by the fire department.
We have to respond to what that signal is.
Absolutely. But we're an end device. We're not a control device.
And the fire marshal always comes and inspects this, and this is like the last thing. It's always the fire drill at the end of the job to get it done.
Right. Generally, we've gone through commissioning. We've gone through and balanced the building. All of our air handlers are up and running. We're getting the right duct pressure. We're getting the right temperature through the building. And then generally the fire marshal will come in and he performs these tests. And, we've been really, really good at staying on top of our contractors to make sure that we don't get held up during fire inspection. And it's always the last thing that happens, and it could cost you days if you don't think out in front. And that's why we have the demo. We get that scope of work from the fire alarm contractor long before we ever are on job site. And then we go ahead and simulate it here. I give wiring diagrams and programming. So now the demo, like I said, what we've just kind of looked at right now is just basically, this is the bypass section. This demo here will allow us to also look at standalone drives, or cubes, like we call them. And so it's really simple to make that transition here, because
just for everyone else, a cube is just a drive without bypass, anything else. It's just the cube, the box.
It is the device that actually produces the variable frequency.
Right.
Because we're using it right now. I just have a blank in the cover.
Yeah.
But it is what actually produces the PWM waveform. Okay. So what we're going to do real quick, John's going to demonstrate this for me, because really, it has the same switches, the same functionality. The only thing that is not incorporated into the design that John's getting ready to work on is the bypass portion of it. The bypass control board does not work any longer, and there is a control board on the inside of that drive that actually performs the same functions and has the same inputs I have here. So we're going to go ahead and shut the unit down, and we're going to flip this to drive only. John is going to go ahead and install.
So we're putting the keypad?
Put the keypad in now.
So this is just a blank out panel?
That's just a blank out panel, because I don't want people to get confused.
Yeah.
So.
And then here we got this keypad, and it just drops in. You put the bottom in first, and then just make sure it lines up, and just plug it in.
And then we just turn the power back on down here.
Got it.
So now when it powers up, if you'll notice, the first thing that comes up is what, John? It comes up and it says idle.
It says, off, and then it gives me a frequency reference and an output frequency reference.
So take the handheld.
Yep.
So what we're set up in now is we're set up in the cube only, which does basically that is where the actual variable frequency takes place. And John is holding the interface, which would be like a building automation, dry contact closures that perform the functions. The two switches that are over on the right are what we call safe torque off. And what they do is, if they were in an industrial application or anything, if the minute it senses a difference in torque, it goes ahead and precludes VFD operation. It shuts it down. And like if somebody was to stick their hand in a saw or anything like that, it would sense that torque difference and go ahead and immediately shut the drive down. And then if you'll notice, it has 8 switches, just like we discussed on the bypass control. Those are my 8 programmable multifunction inputs. The one that is on the far left towards me would be my start input. So if John was to flip that one up, you would see on the drive the green light up in the upper left-hand corner that says run would start. And if you'll notice, the top line is telling me how fast it's telling me to run, and the second line is how fast I'm running. The green light that you see above here, that green light tells me that the drive is happy. Now, if you'll take the adjustable dial that's on the left and begin to turn that to the right, the drive will start speeding up.
Yep, there we go.
Okay, and so what that is just like a variable frequency analog input, and as he changes that speed, the drive will speed up and slow down to match that. based on our acceleration time. But again, this is what we use the demo for, is I can come in and we can build a program, drop it in there, and then I can simulate everything that they're doing in the field before they ever get there.
That's
Okay?
awesome.
All right. So basically that's kind of like what we have in our demo unit here that we use. It's been a very, very useful tool for us, not only for training our people, but for training our customers as well. The third thing that we do, and we use this as a tool, is what we call Drive Wizard. And this is a PC-based control interface, and we're going to go ahead and flip the unit back over to bypass for right now. So I'm going to go ahead and cycle power. So now what we've done is we've gone ahead and we've moved back into our bypass control, and if you'll notice, we have a USB cable to FireWire, and what it is this is going to be our comms. Now, what I do to connect to the drive, I can do this when the drive is running, or I can do it when the drive is, I can do it when it's not connected to the drive, and I build my programs here, and I can either put it on a flash drive, or I can put it in the keypad, send it with our tech, or I can build the file, and as long as they have Drive Wizard on their laptop, I can just send them the file and then email them the file, and then they have it out in the field and they go ahead and upload it. And the upload and the communications is fairly simple. If you'll notice the drive, it's called Drive Wizard, and what I do is I select my drive, and I've already selected this particular drive. Since it is a demo, it's got kind of a weird number, but I already scanned for the drive. Then what I want to do is I want to go ahead and I want to test my connection, and that'll be down here in the lower right-hand corner. I test it. As long as it's good, the blue line comes across, and everything says, okay, you're connected to the drive. Once I've done that, I connect to the drive and go online. If I was to select offline, it would just pull a parameter set for me, and I would build off of that. But if I want to go online and actually communicate with the drive, I go online. That's what we're going to do right now. And so now what I'm doing is I'm retrieving all of the data out of the demo right now and pulling all of the parameter sets.
Okay, so you could run a test, say, okay, this is what we want, suck it out, put it in your laptop, and then
I can even make changes.
Distribute it from there.
Yeah, and that's what I want to demonstrate here for a second. If I come over here and I say read all parameters from the drive, or edit all parameters from the drive. If I pull that up, it's going to pull everything up. Now, it gives me every parameter available to me through the keypad and as well as register data. So if I want to come through and look at only what I've modified, I can come over here, take a look at modified parameters, and it will give me in red what I've changed. So in other words, if I go through and I pull it up, I can say, okay, what changes did they make in the field if it was an existing drive? Take a look at that, pull it in. If I don't like those, I can actually, in real time, make a change, hit upload to drive, and it will go ahead and upload the new program into the drive.
Okay.
So what it does is it allows me not to have to go through the keypad and go through the menu tray.
Yeah, will it keep some trending as well? So say like you get it set up, you go work on, you start up more drives, you come back and you realize something faulted, something went out, you got to change a parameter.
Right, and we can retrieve the history, and once we retrieve the history, we kind of get a good idea of what parameter is probably not where it's supposed to be, and so we can go in there and we can troubleshoot that. But once we get done with the drive, we can come over here and go to Startup and Diagnostics, and I have trending available to me. So when I go ahead and select trending, it pulls up this screen, okay? Now I can trend whatever I want to. Right now I've got it set up to trend my frequency reference, my output frequency, and I'm also looking at output power because that's usually what I want to know, because one of the reasons we apply drives is for energy savings. And so most of the time, a building manager or somebody, they want to know what their kilowatt usage is. This will trend that for them, and so they'll be able to tell throughout however long period they want to, what their kilowatt usage is. So we're going to go ahead and start this just so you can see it, and we're going to run it. Now remember, this is a demo unit. I don't have a load, so it's not going to show up as pronounced as it would in the field.
So in doing this, we took this controller back out and you plugged back in, so you're controlling this.
Right. Right now what I'm doing is I'm controlling everything. I'm not going to control it with this. I can, but I'm going to go ahead and control it with the switches like we normally would. But right now what I'm communicating is the bypass control board. The bypass control board is communicating with the cube through BACnet. We have BACnet on board. Okay, so if I go ahead and I'm looking at those three trends, I can come over here and start the trend. So right now I've started the trending and I'm going ahead and looking at it. And right now what you see is the red line that goes across the trending, and you might not be able to see it where you're at, but it gives me a countdown of what time it is. And this is real time. There is a real-time time clock built into it. And so we're looking at 10:50:04 and I'm beginning my trend. The top red line is my frequency reference. My blue line is my output power. Now the only thing you don't see yet is my output frequency because I'm not running. So like we were before, this is our potentiometer for how fast I'm going to run. Here's my run command. We're going to go ahead and start the drive. And you'll be able to see the trending begin to come up. The black line is my output frequency. Eventually it will come up and meet my red line. If I had a load that was large enough, the blue line is my kW usage. And so we would hopefully trend with it and then come up. And then as our load went up and down, they'd be able to see. Now, if I change speed on the drive and I move it up, okay, now we see we've changed the speed, the drive should be able to come on up. So basically what I'm trying to show you is that we can go out there, get in front of this drive and run this and look at whatever parameter we want to and trend that and turn that into an energy auditor or whatever, and he can use that to his, you know.
Yeah, great tool.
Great tool.
Yeah.
So basically, when we get done, the other thing I wanted to show you guys on the trending, or not on the trending, but on the computer programmer, is with Drive Wizard. What Drive Wizard does is it gives me the ability to go ahead and I can connect to any family of drives that Yaskawa builds. I can go all the way back to the E7 drive. So even if this is a drive that is 22 years old, Drive Wizard will figure out a way to communicate with it. And so everything that we've done for the last 25 years, it doesn't matter what building we walk into, our techs are equipped when they go in, as long as they have this tool, to be able to do what we did here today.
It's really valuable.
Very valuable.
Yeah.
And we're going to continue to use it. We are moving into our low harmonics drives that eventually we will have a model for that. It's just not available yet.
Well, cool. Number one takeaway, what's the value of having your wizard in a demo?
The value of having this is being able to not be under the gun out in the job site. You can do a lot of this work pre-visit. And so if you have just a few of the small details, you can go ahead and work them out in your van, in your office, at your house, whatever. You can work out a lot of these problems. The other thing is it allows us to be a better partner to the other skilled trades and to our customer, because we're able to offer them answers long before they get out on the job site.
And you can test it, and you got a lot more confidence when you go talk to other people on the job site.
Absolutely. When we have a scope, then there isn't anything we cannot simulate on this. And that is the value, because most of the time we're guessing. We get out there, we show up on the job site, contractor comes up and says, I need it to do this. Well, if we didn't know that, we have no way to, we're having to figure it out on the fly. This eliminates the time that we spend on job sites.
Yeah. All right, that's great. Anything else?
No, I mean, the biggest takeaway I want everybody to get from this is that we're taking this opportunity to not only train our techs, we want to train our community. We feel like the more that everybody knows and the more knowledge that we share as far as VFDs, they've been a black box for so many years. We want to just take the opportunity to show you that we can come in, we can bring this model to your office, and we can train you in your office with this. So that's been the biggest takeoff from this.
That is.
So
totally agree. The more people know, the more enthusiastic they get, the more confident they get, the more solutions they find.
Right.
Yep. All right. Well, thanks, Jeff. Always great to be with you.
All right.
Hey, hit that like, hit that subscribe. Thanks so much for checking us out on Mechanical Pros, and come back and see us again.